Hello? Hello. Okay. Been a bit. Let's see here. I am moving a bunch of functions that I consider required for the language's function to be part of this intrinsic function enum. Mainly so that in the VM, which is what I'm calling the thing that does compile time execution, rather than do a hackish intercept call thing where I say, hey, if it's memcopy, implement it ourselves, or if it's alloc, so just sort of reaching in and grabbing functions, just sort of, you'll be just prompted to implement every intrinsic, and then it makes a lot more sense. So, yeah, this code will stay, but it'll move to like a match on the actual intrinsic type instead of this detect intercept style thing that looks for functions it wants to intercept. So be a lot clearer, and then there won't be like a fake implementation that doesn't run because the VM intercepts it. Hope that makes sense. So just diving in here. So far I have all the allocation functions, some memory ops, and then exit as my plan. Exit's a big one to be done this way. I think it helps out a lot. Panicking is still something I don't fully understand how I want to handle. I do have unwinding using libunwind. In the VM, it's pretty easy. I just make a compiler error saying the VM exited or the program crashed. Anyway, that's where we are. So we have these, and really this is more of a problem in CodeGen. Kind of a pain because in LLVM, where I used to not have to do anything for these because they were just libc calls, just foreign function calls basically. Now they're intrinsics that I have to implement. So that's a bit frustrating, but here we go. So there's malloc that I just did, and I don't really have a great way to test this iteratively. Allocate and allocate zeroed. Oh, and one more thing. I decided that turn fun system alloc. I decided to require an align for all of these, even though libc doesn't, and then for free I'm requiring size and align because I've seen all allocator APIs do it this way, and I figure it's probably a good idea. Even though I'm just calling libc and won't actually use these. So when I call alloc, I'm just passing the size to malloc, and I don't need the align, but I still require it. So we're just gonna pluck the first argument there. So that's what's up. Allocate zeroed is like the same thing, but with a calloc. And the problem there is actually that it takes a count. So, oops. Looking at what I do for, count one size. Let me just pluck this before I revert it, and then place it here for reference. So it still requires the size first. So, and that's actually still, And all that means is we just need count one, where count is a calloc a U word. So we need to make a U word here. So this is going to be self. We want a pointer sized int const int. Whoa, that was cool. Constant 1, sign extend, false. As basic value enum into, what a mess. So this will be like count 1. Ah. Oh, and it knows. Wow. It's weird how Rust's type inference goes backwards. I still want to do the into here, though. And it's just basic value, you know. Okay, kind of gross, and, you know, not... I mean, I could do some helpers to grab the arguments out, perhaps, and calling this is interesting because I'm not sure these are going to be here, unless I add them explicitly. Oh, yeah. Anyway, one thing at a time. So realic's the worst for sure. Go back to what I had. Yeah, so pointer new size. It's not that bad. I'm also not going to do the null checks that I was doing here. This is just the system allocation call, and then I might wrap it with something that returns a result. I haven't. No, not that returns a result, but that crashes on null. But oh, let me grab that as well. And I might as well grab free. Well, free just takes one, so that's fine. All right, pointer new size. So size var, size value. Let's write a helper. So this is just gonna be fun. Load function argument. This is the only place in the backend that I do this. It's really strange to have to operate this way, but it just has to do with the way I represent function parameters, and it's weird to have to, you know, basically build the code myself and like program in LLVMIR here. So, and this is just going to give us a basic metadata value enum, which is what calls require. And it's kind of just this whole thing. And we just need the type ID. Oh, but what's cool is I know the type because I can just be like param type function. So the params. Oh yeah. I thought these moved to the type. It's function. Function params. No, these are function type params. So it's a totally different thing. A function type param in this language is a way that I allow a function to take a function generically of any kind. So it's a function type param. What I want is to grab the type of this function and then get its arguments. So let's just make sure that rename went through. Looks like it did. So we'll just go into, we have a get function type. So this is going to be more like a self.module.get function type of our function. Doesn't have its own ID, so let's just do it more simply. Types get the functions type, and then we're going to expect a function type, which I don't have a helper for, which is a little surprising. I will go ahead and do this. Okay, this can be a ref of a function type, I guess. Yeah. Fun type. Now, what are logical params? Oh, lambda, right. Skipping the lambda environment. Well, none of these are lambdas. Ah, yes, and I need an index. I could hardcode all of these types, but this is better. This is pretty piss poor performance, this whole thing. I mean, it's not terrible, but it's pretty suboptimal. Variable value, basic value. And we'll just make this a codegen result so we can question mark this. And this can be an okay, basic value into basic value, basic value, basic value. Yeah. Okay. So this will just be oh, I want that one. Don't even need the function value yet. And that gets better. And this one, the size arg is 1. And count 1 comes first. And count 1 needs into, and this one does not. That's a size argument. Alright. And now reallocate. New size arg. Oh, that's no one. And can you guess? Mm-hmm. That's good. And now we just need free. And which is just old putter arg. It's this whole thing with only old putter arg. And it's free. And that's realloc. Calloc. Free. And for each one of these, oh man, mem copy, mem set, mem compare. This is an LLVM intrinsic. Oh, and memmove. I don't have memmove yet. We'll need to add that. Dest. I like using DST because it goes better with SRC. Dest align, source align, size. This is like, we call this when we're moving a struct, like as part of how the language is implemented, not like when the user calls memcopy. So we don't necessarily need to reuse this. We're not gonna, yeah. We just need to use what we're called with. But the align, is interesting because I don't think I have it. What is that alignment for? I don't understand why their memcopy needs an alignment. Do I just say 1 byte? Because this is operating on bytes? Do we give AI a go? Let's give AI a go. All right, here we go. Why does LLVM's memcopy intrinsic take alignment arguments? What do they do? Does it operate bytes? So line equal 1, I would think. Okay, it's cranking. This is how I've written it in K1. Ah, and you want pointer values. So now I'm a victim of trying to factor out code because I don't want all of this. I don't want the metadata conversion. I want these. Okay. I can go straight back into pointer value. Fine, really inefficient. Just not it's just downright waste like indirect. But that's okay. If it ever matters that emitting the LLVM IR is faster in the face of everything that happens in the front end and everything that LLVM does later with the IR, that will be an easy problem to solve. But what are we looking at here? What does this return? This returns a, well, pointer value. But do we use that return value? Yeah, we say we return a pointer, so we should return a pointer. That's fine. be a little bit declarative here. And what did it say? Minimum alignment of pointers. Letting compilers use faster copy instructions. Okay, so in this case, we don't know because the user calls this. If the user could tell us the alignment. Mm-hmm. Right. This makes sense. It could just like treat it as, for example, like a U64 if it knows it's aligned correctly. But if it's at some random boundary. I mean, I should probably read this whole thing. This was, I think, a good response. Uh-huh. Right. So this makes me think, where all in user code am I calling memcopy, and do I want to require an alignment so that it can be a lot faster or, you know, possibly more optimized? So make buffer. So in theory, this guy is aligned to T. So this is my like contiguously allocated array that I call buffer. So we could use a line of T here. Which makes me wonder, what is malloc? Ah. I do pass an align to malloc, and that's why. Oh, what a can of worms. This is feeling like a to-do. So I can do libc/memcopy. Oh, that's my only one. And I have an alignment here. And I'm already requiring it. See, not bitwise, built-ins. The fact that I decided to require them for all of these, you know, makes me think that doing it. Oh, this is already mem. I was thinking that, yeah, we can put memcopy. This is great. What am I gonna call it? Mem/copy, because we're in mem. Copy. Dest. Source. Oh, I know. will do too. Copy, you know, unaligned or whatever. It's a bad name, but you know what I mean. So this is going to be dest align, source align, count. That's not a hard function to call incorrectly at all. And memcopy does mem3. Yeah, it returns the pointer, the original value of dst. Well, we should still declare that correctly. But what I was going to say boom. How about that? We'll get there when we get there. I might as well do it now. Mem/set. We're gonna call this as mem/set. It's gonna be so good. Now, does LVM give me a mem set? It sure does. And that's the same. So let's just basically expose LVM's mem set as well. And then if you don't know the alignment, then I'll pass 1 for you. Dest align by its value size. Shoot. What's the value? I think this is the number of bytes to fill. Okay. So what should I use? The number should probably just be uword. Hopefully it takes. I'll just do putter sized int. Yeah. Okay. So it's the byte value, IA val. Why don't I just copy this? Oh, that was poorly done. Okay. That's one more done. Oh. Oh! Plot twist. This wants a compile time U32, not a runtime U32. Well, that I don't have. That's totally different. Yeah. Because this is all just runtime. This is for runtime known. Yeah. Okay. Yeah. That's a little bit of a bummer, but we're here. We're here for the understanding. Oh, I do one memset. I free an arena, which is actually not really what you're supposed to do. You're supposed to just move the pointer back, because the whole point is that it's mega fast. So let me just remove that. Not really using it. And worry about my arena implementation being really basic later. And let's just try to do, and let's do mem compare. this, right? And there is no memcmp. So this one is going to be like the call style. That's that. Now I need to stop calling these. No one's calling that either because I've started using exit because it's more appropriate. Okay. Oh, yeah, my face is over top of this. Great. Great. All right. We'll figure out exit later. So what I would try to do now is just try to compile my stuff and everything is gonna fall apart. Okay. Exit in the VM I actually can do. Because here I'm supposed to be returning a VM result. Yeah, so I can just be like, okay, value, no. VM result, exit, code. So we're not in LVM anymore. We're in our VM, our interpreter. Code. This is execute expression, expect a value. Well, okay, I guess you could panic. Yep, that's fine. And we're just gonna expect an int. And A32, it's supposed to be, and then we're just gonna else what we just do is we just say like malformed exit code type, something like that. And so we have a code, and then we exit with a code, and now we just implemented exit in our VM. And I expect to see, yeah, could not resolve. So we added these intrinsics, so resolve resolve parsed function call intrinsic. Where do I like detect them? Oh, resolve intrinsic. Right. So bits char pointer. Ooh, mem refit pointer refit index. This is my get element pointer, which I guess you could implement yourself with a multiplication, but it's nice that it compiles directly to an LVM gap. This could be in mem too. Mem, something like index type. But anyway, let's get in here with mem. So this is where we actually decide what what the names are in the source code. And is this the time to ditch these kind of heavy system prefixes? The reason it's prefixed with system is because I have a whole, the plan is to have a whole allocator API in system. So I want it to be really clear that you're just calling the global system. Whatever the system provides, you're not calling like into maybe the allocator you have configured for the thread or something, which will be the norm. But just mem/alloc seems sufficiently systemy to me. Yeah. Mem/alloc, mem/alloc zeroed, mem/realloc, mem/free. We're gonna do it that way. And do we say allocate? I don't think we do. That is the right name. Oh, right. Deallocate is better, but free is so fun. Free is so ubiquitous. It's free. Free. The name works so much worse, but what are you gonna do? Because you have like a double free, you know, like use after free. These are what it's called. It's not use after deallocate. I don't have move. I'll exit somewhere else. These could just be insist. No, mem is good. Okay. Ooh, function not found. Ready? Ready? Whew. That felt nice. That's not bad. So this is what I was talking about, right? Like what you actually call is alloc in, or you call alloc init, resolves to assumes you want whatever the current one is. And only if the mode is set to system heap do we call the system one. So this system name, you know, maybe I should have brought back those system prefixes, but you know. Yeah, it's not that. It's system Alex zeroed. Which could just be like Alex Z or something. Oh, and then we compile. So that wasn't too bad. But that's not the LVM. That's just type checking. So now it blows up. Boom. One thing that's a problem, look how deep this stack is in LLVM codegen. And it's because of this. Codegen function call, codegen function or get, and then we codegen the function. So it goes as deep as the source code's call depth can go, which is bad. This will overflow once functions get interesting. So this needs to not recursively codegen the function that you call. It needs to just create the signature and then go back and fill in the bodies. It's much easier than a lot of the stuff we're doing in the earlier phase. It just hasn't mattered yet. So let's add it to do, actually. I think this is going to be, and I kind of want to do this before I wrap what I'm calling this VM project. So I'll put it here. Or I'll put it like, yeah, I'm doing it. Okay, cool. So things have kind of moved around. I want this to do back. I did do proper basic comp time, just not with a VM. So, yep, and I do have an allocator system. It just sadly runtime branching. I want it to be compile time branching, so a little bit of to-do cleanup. And now we're back to static execution. And what I wanted to say, oh, boom, we're at the tail end of that. And what I wanted to say was, LVM codegen call stack is too deep due to codegen function or get. That can be first class. Okay. Unwrap on and on. Intrinsic function body 2941 D386. Right. So as I said, these may not be here, but we do declare them. So in built-in, we're going to okay. I kind of like how I did this, actually. I need calloc, realloc, malloc, calloc, realloc, and free. So we do need malloc, calloc, realloc, and free. Whoops. You know what? No, don't allow them. So if I declare these, will these just happen to run before I happen to call them? Yeah, because the place where I panicked, I'm doing bodies here, and no, that's not true. In the back end, I don't do signatures then bodies. That would solve my call stack problem, but I don't do that. So that's what we need. Actually, let's update that to do. Yeah, so we don't, even though I restored it, So I could obviously just declare these programmatically, but I want to not do that. Interestingly too, yeah, I only want to do this in the LLVM backend. Obviously I don't want to try to link to these in the interpreter. So yeah, so I just code gen main. Yeah. I only code gen what's called, except for globals. So what I could do is like go get the libc module, and then I would hardcore no commit this, commit. All right, actually, if oh, perfect, it has the identifier. This is gorgeous. What do I do? If it's one of the ones I really care about, I just kind of run it. And the thing is, I think for functions with external linkage, all we do, yeah, if it's external, we add it, and we do a thread shit, we insert it, blah, 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 and if it's external, we don't do the body, we just return. Exactly what we want to do. And that's the wrong, so can I do this? So here's our hack to get our stuff run. I need semicolons. Am I allowed? No. Come on. This is found to be of type function value. Do I really have to wrap all of these in braces so that I can give them a semicolon? I mean, Lord. Can I do after the match? Yes, I can. Yeah. No. Yeah. Jeez. Okay. Okay. Piss off. Yay! The given type is not a basic type. Intrinsic function body 2981. Entered unreachable code. Build mem copy. What? Let's print that sucker out. No. Says it returns void. LLVM.mem copy. Why is it saying it returns void? If Inkwell says it returns pointer. What was that other one? UCMP. That was interesting. Okay. Oh, void. Weird. What is he saying? Try to put size type. We'll get you one of those. Okay. This isn't my fault, I don't think. So what? But it says it returns a pointer value. I mean, memcopy is supposed to return the destination pointer anyway, right? Yeah. This is gonna be totally wrong stuff. Not actually a yeah, it's a call. So it's an instruction value, just typed wrong. Memcopy. I mean, this makes me think, why should my memcopy return? Oh, I gotta go to bed. Yeah, why should mine return something? Right, it just returns a destination. I mean, screw that, right? Like, let's return unit. There's no information in there. If I get to implement it in here, so memcopy, I'll just return unit, self dot built-in types dot unit basic, and memset. Just copy in the signature for later. Let's copy in the signature for copy too. That's nice. Compare. Do the same. Okay. (302) memcmp You seem to be trying to use. Okay, you know what? I am. That was a good one. Oh my gosh. We're infinite looping inside of crash, which is trying to build a string. Cool. This is actually my backtrace code, which is neato. Wait, no, we did crash. No. Did I let it? Okay, let it overflow. Where are we doing this? In generic enum. Wonder what's going on here. Well, all we did was change every core function. This is why you don't change so many things at once, but this just would have been hard to do one by one. Oh no. My debug info is broken because of something, something to do with these intrinsic bodies. Well, that seems like a great stopping point. Nothing is working. We have a hack to get nothing working. And all we're doing is shuffling stuff around, but that's the grind. Thanks for watching.